Today, we'll explain how this light-sensitive LED control circuit works, with a special focus on how we can use the potentiometer to adjust the sensitivity of the circuit. 1. Power source. The circuit is powered by a 9 volts battery, BAT1. The positive terminal of the battery supplies power to the entire circuit. 2. Light detection. LDR1 is the light-dependent resistor. It changes its resistance based on the light intensity. When there's bright light, its resistance decreases, and when it's dark, its resistance increases. The LDR is part of a voltage divider with a fixed resistor, R1, 10 ohms. 3. Role of potentiometer, RV1. Now, let's focus on the potentiometer, RV1. A potentiometer is a variable resistor that lets us adjust its resistance by turning its knob or sliding its control. In this circuit, the potentiometer is connected to the inverting input, minus, of the operational amplifier, U1. How does it works? Think of the potentiometer as a way to set a threshold voltage. This threshold voltage determines the light level at which the circuit will decide to turn the LED on or off. By adjusting the potentiometer, we are effectively changing the voltage at the inverting input, minus, of the op-amp. The voltage you set here will act as a reference for the comparator. Fine-tuning sensitivity. When you turn the potentiometer knob, you change the resistance in the path, which in turn adjusts the reference voltage. For example, turning the knob to the left, counterclockwise, decreases the resistance, lowering the voltage at the inverting input, minus. This makes the circuit more sensitive to light changes, meaning the LED will turn on at a lower light level, even in a dimly lit environment. Turning the knob to the right, clockwise, increases the resistance, raising the reference voltage. Now, the circuit becomes less sensitive to light, meaning the LED will only turn on when it's much darker, ignoring small changes in light levels. Practical example. Let's say you're using this circuit for an outdoor lighting system. If you want the light to come on as soon as the sun starts setting, when it's not fully dark yet, you would turn the potentiometer to make the circuit more sensitive. But if you only want the light to turn on in total darkness, you'd adjust the potentiometer to make it less sensitive. 4. Operational amplifier, LM741. The op-amp U1 compares the voltage between the non-inverting input, plus, and the inverting input, minus. The voltage on the non-inverting input comes from the LDR and R1 voltage divider, which changes with the light level. The voltage on the inverting input is controlled by the potentiometer, RV1. When the voltage from the LDR circuit, non-inverting input plus, is higher than the potentiometer's set voltage, inverting input minus, the op-amp outputs a high signal. This turns the LED on. When the voltage from the LDR is lower than the potentiometer's set voltage, the op-amp outputs a low signal, and the LED remains off. 5. LED and resistor. The LED, D1, is connected to the op-amp's output. A current-limiting resistor, 1 ohm, is placed in series with the LED to protect it. When the op-amp output goes high, the LED lights up, indicating that the light level has fallen below the threshold. 6. Working principle, with potentiometer focus. In summary, the potentiometer, RV1, allows you to set the threshold for when the LED should turn on or off, based on the ambient light. The LDR senses the light, and the op-amp compares the light level to the reference voltage set by the potentiometer. Adjusting the potentiometer lets you control how sensitive the circuit is to light changes. Blank, underscore, blank. Conclusion, with emphasis on adjustability. In conclusion, this light-sensitive LED circuit not only responds to changes in light, but also offers flexibility through the potentiometer adjustment. By turning the potentiometer, you can fine-tune the sensitivity of the circuit, choosing when the LED should turn on based on how bright or dark the environment is. This makes the circuit adaptable to various applications, from dimly lit rooms to complete darkness.